engines. Every gallon of gasoline begins its journey as thick, black crude oil. But how does one of Earth's darkest natural resources? Crude oil isn't manufactured by humans. It's a natural mixture of hydrocarbons that formed deep beneath the Earth's surface over millions of years. For millions of years, buried organic material was transformed by heat and pressure, eventually becoming the crude oil trapped. But how does that hidden oil travel from deep underground to the surface? The answer begins with an extraordinary piece of engineering. So how do engineers safely extract crude oil from thousands of feet below the Earth's surface? That's where the journey truly begins. Modern drilling rigs can reach oil reservoirs buried thousands of feet beneath the Earth's surface with astonishing precision. As the drill cuts through layers of rock, drilling fluid cools the drill bit, stabilizes the well, and carries broken rock back to the surface. Oil isn't stored in giant underground lakes. Instead, it's trapped inside tiny spaces within porous rock formations deep below the ground. Before oil can be produced, engineers install multiple layers of steel casing and cement to isolate the well and protect surrounding groundwater. Spumas. Once safely extracted, crude oil begins the next stage of its journey, traveling from the well to one of the... After arriving at the refinery, crude oil enters one of the most advanced industrial facilities ever built. But what happens first? Before crude oil can be separated into useful products, it must first be heated to extremely high temperatures. The heated crude oil now enters the refinery's most important structure, the distillation tower. But why doesn't everything stay mixed together? The answer lies in one simple scientific principle. Every hydrocarbon boils at a different temperature. From a single stream of crude oil, the tower begins separating the raw material into the fuels and products that power modern life. Inside the distillation tower, the hottest vapors rise naturally, while the tower becomes cooler and cooler toward the top. Heavy hydrocarbons cool first and remain near the bottom, while lighter molecules continue rising toward cooler sections. Each level of the tower collects a different petroleum product, simply because every hydrocarbon condenses at a different temperature. Gasoline forms higher in the tower than diesel because it condenses at a lower temperature. That's the simple science behind the entire refining process. But the gasoline leaving the distillation tower still isn't ready for your car. It must go through several more refining processes. The gasoline leaving the distillation tower still isn't finished. It now enters another stage where chemistry improves its performance.
One important process is called catalytic cracking, where larger hydrocarbon molecules are broken into smaller ones that are better suited for gasoline.
Another process, called catalytic reforming, rearranges molecules to produce cleaner-burning, higher-octane gasoline. Refineries carefully blend different fuel streams to achieve the exact performance, efficiency, and quality required for modern engines. Before leaving the refinery, every batch of gasoline is tested to ensure it meets strict quality and performance standards. One barrel of crude oil doesn't become just gasoline. It becomes an entire family of products that power modern life. From the same barrel, refineries produce gasoline for cars, diesel for trucks, and jet fuel for aircraft. But the story doesn't end there. The same refinery also produces asphalt, lubricants, heavy fuel oils, and liquefied petroleum gas. Many everyday products, including plastics, synthetic fibers, medical supplies, and packaging, also begin their journey inside an oil refinery. Once refining is complete, these products begin another incredible journey across the country. But how do millions of gallons reach gas stations, airports, and cities every single day? Once refining is complete, the fuel begins another incredible journey. But it doesn't head directly to your local gas station. Much of America's fuel travels through thousands of miles of underground pipelines operating around the clock. Before reaching consumers, gasoline is stored at regional fuel terminals where millions of gallons are carefully managed and prepared for delivery. Here, tanker trucks are loaded with precisely measured fuel before beginning the final delivery to gas stations across the country. From the terminal, the final journey begins. Every tanker truck delivers fuel to the underground storage tanks waiting beneath your neighborhood gas station. Before any fuel leaves the refinery, every batch must pass a series of strict quality tests. Scientists verify the fuel's octane rating, purity, volatility, and chemical composition to ensure reliable engine performance.
Even small differences in fuel quality can affect engine efficiency, emissions, and long-term reliability.
Thousands of sensors continuously monitor every stage of production, helping maintain consistent quality and safe operation around the clock. Only after passing every quality check is the fuel approved for distribution across the country. But how does it travel hundreds of miles to reach your local gas station? After leaving the fuel terminal, tanker trucks begin the final stage of the journey, delivering gasoline directly to local gas stations. Before unloading begin, strict safety procedures are followed to protect people, equipment, and the environment.
The fuel doesn't stay inside the truck. It flows into massive underground storage tanks hidden beneath the gas station.
From those underground tanks, powerful submersible pumps quietly deliver gasoline to every fuel dispenser above.
From deep beneath the earth to the fuel tank of your car, every gallon of gasoline completes an extraordinary journey powered by science, engineering, and precision. You might think all crude oil is the same. Surprisingly, it isn't. Different types of crude oil require different refining processes.
Light crude flows more easily and naturally produces a higher percentage of valuable fuels, like gasoline and jet fuel.
Heavy crude contains larger hydrocarbon molecules, so it must go through additional processing before it can become high-quality transportation fuels. Refineries are often designed to process specific types of crude oil, depending on where that oil comes from and its chemical properties.
That's why modern refineries are among the most complex industrial facilities ever built, each one carefully engineered.
Not all crude oil has the same chemical makeup. One of the biggest differences is the amount of sulfur it contains.
Crude oil with very little sulfur is known as sweet crude, while oil with higher sulfur levels is called sour crude.
Sweet crude is generally easier and less expensive to refine because it requires less sulfur removal before becoming clean fuel.
Sour crude can still produce excellent fuels, but it must first pass through specialized desulfurization units that remove sulfur before the fuel reaches consumers. Removing sulfur doesn't just protect engines, it also helps reduce harmful emissions, making today's fuels significantly cleaner than they were decades ago.
Modern oil refineries don't just produce fuel, they also invest heavily in systems designed to reduce emissions and protect the environment.
Specialized pollution control systems capture or reduce many harmful compounds before gases are released into the atmosphere.
Water used during refining is carefully treated through multiple purification stages before it is reused or safely discharged.
Thousands of sensors continuously monitor environmental conditions, helping engineers detect problems and respond quickly if conditions change. Producing fuel on this scale requires more than engineering. It demands constant attention to safety, environmental protection, and continuous innovation. Today's oil refineries aren't controlled by switches alone. Thousands of sensors and intelligent computer systems monitor every part of the refinery around the clock.
Artificial intelligence can detect tiny changes in equipment performance, helping engineers fix problems before they become costly breakdowns.
Many inspections that once required workers to climb dangerous structures can now be performed by drones and specialized robotic systems. Some refineries even use digital twins, virtual copies of the entire facility, to test improvements without interrupting real production.
Behind every gallon of gasoline is a remarkable partnership between skilled engineers, advanced automation, and intelligent technology working together every second of the day.
A refinery never stops watching itself. Thousands of sensors continuously monitor pressure, temperature, and flow every second.
If a system detects unusual pressure or temperature, automated safety controls can isolate equipment within seconds.
Those tall refinery flames are usually safety flare systems, designed to safely burn excess gases during certain operating conditions.
Refineries regularly train emergency response teams and test their safety systems, so they are prepared for unexpected situations.
Behind every gallon of fuel is an enormous network of engineering, automation, and safety systems working together every hour of every day. Every gallon of gasoline passes through one of the most advanced engineering systems ever built by humans. Despite what movies often suggest, modern refineries are designed with multiple layers of safety, monitoring, and emergency protection. But leaving the refinery is only the beginning. The fuel still has an incredible journey ahead before it reaches millions of drivers. In our next documentary, we'll follow every mile of that journey. From refinery to pipelines, terminals, tanker trucks, from deep beneath the earth to the road beneath your wheels, the journey of fuel is one of science, engineering, and human innovation. And this is only the beginning.